Good morning, students. Last week we discussed architectural symbols. We equally made mention of fittings and fixing, and from there we moved straight to finishing and finishing. So this time around we are going to discuss what we have as metalwork project. Metalwork project. What do we really mean by the word metalwork project? See, this involves the practical application of our knowledge about metal and metalwork to produce various useful objects such as water opener, coal pots, stool, chairs, benches, and several other ones. The process includes designing. That is what we have to do before we can accomplish this project we are talking about. 1. Designing. 2. Choosing a template, choosing a required method, tools and a working machine, measuring, making, cutting, bending, joining, filing, and finishing. The first one, designing, that is the way you are able to design what you want to do. The way you are able to put it on paper, that, oh, this table that I want to make, what is going to be the size of the table, the length, the breadth. So that is what we refer to as designing here. Then using template. Template has to do with the shape that has been produced before, that we now have to assist you at least to produce the real thing that we intend to do. Choosing required method. We have different types of method. Now you are the one to decide the type you want to use. Out of the several types we have, you are the one to determine that, oh, this is the type of method I'm going to use for this, this is what I'm going to use it for this. Because it is not all methods that you can use to do, all projects. For instance, the kind of project that is going to be an outdoor one, you just have to be careful with the type of method you have to use, particularly the one that will be exposed to moisture, to rain, to weather outside. Then tools and working machine, that is the tools you have to use, you are the one to decide. Don't forget, all along we are saying that you have to use the appropriate tool for the kind of job you want to do, and this was going to be able to get a reasonable thing. Then measuring. You have to measure what you intend to do. Marking. That is, by the time you measure, you have to mark where you have to cut and that kind of thing. Then, before you can now think of cutting. The next one is bending. When there is a need for you to bend for one reason or the other, you just have to do that. Then joining has to do with the idea of joining maybe 2 or 3 parts together. Then filing also. Filing is a way of reducing. At times, maybe when you want to reduce a particular size, or you want to take away temperatures that you have other sorts. Then the last but not the least is finishing. That is what you have to do at the end of the project, so as to make it to look somehow attractive. Now, machine motion. Motion simply means movement of or act of moving. That is, movement or act of moving that occur in a system. Engineering system includes 1. Our motor vehicles, jacks, cloths, gears, rails, clamps, trains, and several other related ones. The types of motion. Basically, we have 2 types. We have linear motion, then we have that of a rotary motion. Linear, another name for linear motion is the rectilinear motion. Rectilinear. So you either call it linear motion or you call it rectilinear motion. See, this is the motion along a straight line, and it may occur horizontally or probably vertically. Horizontally this way or probably vertically this way. Then it can be found in a vise. You know what I mean by the word vise? That is the kind of equipment that we always have at the extreme end of our workbench that we can use to hold our work piece, particularly when you want to work on our work piece. like a French said, it may occur horizontally or vertically, that is the movement. Then it can be found in a vice, 1, in the 4, 2, 3, jack, then 4, brake system. So, for instance, look at the jack. When daddy or mommy, when they intend to remove tire from, that is punctured tire from the vehicle, in order to replace it with a new one, you agree with me, there is an equipment we call jack. This is a kind of equipment that you can use to raise the vehicle. You see, by the time you are turning the lever, the jack is the one to be raising the vehicle up so that you'll be able to remove the tire. Then the brake system also, making use of a linear. Now, the second one is the rotary motion. Rotary motion, this is rotating movement that turns or runs circularly in a clockwise or probably anti-clockwise direction in the system. Then examples are found in rotating blade of helicopter, then our ceiling fan, our table fan, our standing fan. The way you see the way the blade moves, that's exactly what we refer to as the rotary motion. Then this principle can still be found in our hand drill. Hand drill, so that is, you know what the drill means? Drill is a kind of equipment that we can use to drill hole on our workpiece. So by the time you are turning the lever, then the drilling bit will be rotating, and in the process, it will be drilling the hole for you. Then gears also. So gears, be it the driver or the driven, the two will just have to be moving in a rotary motion. So still have some other very good examples. Now the next one now we have to discuss is levers. What do we really mean by the word levers? Now, levers are used to lift heavy weights with the least amount of effort that you can think of. Now, the levers we are talking about, we have classes. Now we have first class lever, we have a second class lever, we have a third class lever. The first class lever, load is larger than the effort. That is, the load can only be moved through the small distance. Look at the drawing we have up there. That is the load there. This is the fulcrum. This is the effort. Going by what I mentioned the other time, I said load is larger than the effort. That is, this one is larger than the effort you have to put in. And the load can only be moved through small distance. You can only move this load just through small distance. A very good example of our first class lever is like our crowbar, like our plier, like our claw hammer, like our scissors, like a Hoover glass, bicycle brake, then balance scale, and a few other ones. That's about the first class lever. Then the second class lever. That is the drawing on the board for our second class lever. You have the effort here, you have the load here, then you have the fulcrum here. You can see the difference between this and this now. Instead of having our fulcrum here at the center, we have it at the extreme right hand side. Then our effort at the extreme left hand side, and this is our load in between. So look at the inclination we have here. The load between, that is, we have the load between the effort, which is this, and the fulcrum. Then examples in wheelbarrow. You know what wheelbarrow means? That is the one we use to carry bottle opener. Also is a very good example. Then stapler. That is the kind of machine that we use to staple papers together. Then nut cracker and several other ones. Number 3. That is our third class lever. This is the drawing. Look at our load here. Look at our effort here. And look at the fulcrum here. The effort is placed in between the load and the fulcrum. This is the effort. You have it between the load and the fulcrum. Unlike second class